Yeah. Hello, everyone. I'm Xinxin Fan, head of cryptography at IoTeX. I'm also the co-chair for this task group. Today, I'm happy to present the Pantheon, which is an enterprise-oriented consortium blockchain for IoT. Like we all know, the IoT is all about making business decisions based on the data collected by the smart devices. We basically have these three blocks here. You have all kinds of smart devices collecting the data from the physical world. All those data will be transferred to the backend, doing the further storage processing, also doing the visualization and analytics. So data trustworthy actually is essential for the success of the IoT. In particular, whether the data you provide to your customer is trustworthy will determine how much value you bring to your customers. Then now what's the natural question is, how do we ensure the data trustworthy in the IoT? Which is a very hot topic, have been discussed for a while in the security working group during past years. Briefly speaking, we should introduce a concept, the Internet of Trust Things, or IoTT. So basically, we need to cover the entire data lifecycle for the IoTT in order to ensure the trustworthiness along this process. We need to consider about data collection, data in transit, data at rest, data processing, as well as data retention. So basically, you will cover from the device once they starting collecting data and the secure communication when the device sends data to the backend. Also, securely store the data and doing the processing in a secure manner. Why blockchain matters here? So firstly, let's briefly look at the blockchain here. This is a definition given by the NIST. Blockchain, as the name indicated, is a chain of blocks, and each block includes a bunch of transactions. This network is maintained by a group of nodes in a peer-to-peer manner. So the blockchain basically provides you a tamper-evident and tamper-resistant digital ledgers. And in this digital ledgers, they rely on the group of nodes running it without using any centralized authorities. Two types of blockchains have been widely used in industry. First one is a permissionless blockchain. Basically, it's a public blockchain. In this type of blockchain, anyone can join the network. Also, anyone can read the ledger data and validate transactions. So this type of ledgers basically replicate the high degree of trust. So the other type is permissioned blockchains, which have been discussed a lot in the industry. So this type of permissioned blockchains, they're usually formed by a set of known transaction parties or the institutions. They come together to run this ledger. So the validation is usually controlled by a select set of nodes determined by all the participating parties. And this type of ledger, they replicate the high degree of transparency and accountability. So while I believe the public blockchain is the future, but the permission blockchain is still have the high value in this transition period from the centralized solution we use almost every day to a fully decentralized world. Permission version still give you a good example to help people to further understand the value of this technology and how it works in practice. So one problem we need to first emphasize is what properties does a blockchain bring to the IoT systems? Here are 5 properties that's key features provided by the blockchain. First one is decentralization, which means the blockchain removes the single point of failure embodied in the trusted central authority. In blockchain setting, this network is maintained by a group of nodes instead of a trusted central authority. Second property is immutability. So blockchain uses a cryptography hash function to link all the blocks together, which means once the information gets into the blockchain, it's very hard to change that. Third one is transparency. So blockchain provides a fully auditable and valid ledger of transactions. So every participant in the systems can see that. The fourth one is about security and resilience. So blockchain uses public key cryptography and digital signatures to prove the ownership of the data, which means once you send something to the blockchain, the only thing you prove is you are holding the corresponding private key. And also allow the ownership to be transferred. So which means if you transfer the certain asset from one entity to the other party, you can use your private key to do that, to authorize this transfer. Since the nature of the blockchain, the information is widely available across the entire network, which means if some nodes go offline, that's fine. Your information is still widely available. The last one is automation. So blockchain provide a very useful tools here called smart contract. So basically, it's a piece of code deployed on the chain, and you write your business logic in the certain programming language. And the main purpose is to streamline the complex business processes. So these processes usually involve multiple intermediaries in the real world. The smart contract can help you to streamline the complex process. This is all the key features blockchain can bring into the IoT. So why do we working on another enterprise blockchain, considering there are also a number of consortium blockchain existing practice, such as Hyperledger, Ethereum Enterprise version, R3 Coda, the recently emerging one, the baseline protocols. Also, the cloud providers like Amazon and Microsoft Azure also provide the blockchain as a service to give the people who are familiar with the cloud computing the similar experience when they use blockchain. So why we want to work on another one? All the existing solutions here, most of them are very generic solution. You can build many type of applications on top of that. Some consortium blockchain is more specialized. For example, the Coda is mainly using the banking industry for the payment purpose, and Amazon and Microsoft, they manage their own blockchain service. The reason we want to working on a new one is that we realize there's not a good one, especially dedicated design for the IoT purpose. So we try to build a new one to include all the services related to the IoT applications and eventually provide the end-to-end security. That's why we are actually working on the Pantheon, which is an enterprise-oriented consortium blockchain dedicated design for the IoT. This is a high-level tech stack we are envisioning. We have the IoT device layer, capture all different kinds of IoT devices and communication protocols. Second layer is a hybrid layer with a consortium blockchain and cloud. Building on the second hybrid layer, we have the core IoT services, including the user management, device management, storage management, etc. And above this is the application layer. So user can develop all kinds of IoT-related applications above this. So the Pantheon is completely open source. You can access the repository here. And we are going to provide the core IoT services to cover the different IoT applications. The goal is to enable the end-to-end security from the device to the backend. So our initial release is mainly focused on the user management. And the other core services are being actively developed by our development team and will be gradually added into this technical stack. Regarding to the system architecture, this is what Pantheon looks like. We have a number of institutions which coordinate to run this consortium blockchain. We have the blockchain node API gateway to access all the functions inside these blockchain systems. We have a consensus group list, which is a number of institutions who are running the consensus algorithm. Here, give an example flow when user want to query data from the blockchain. For example, they will query the API gateway to get the hash of the data they try to access. They will query a data access proxy to retrieve the data from the off-chain database. So the data access control policy database will check whether this user has a certain permission to access the data. If the permission is granted, user can retrieve the data from the database and compare with the hash they retrieved from the blockchain. So this is just a simple example flow to show how the data integrity can be ensured using our consortium blockchain system. You can use our blockchain explorer to check what's the last block, all the transactions, and the nodes who are maintaining these blockchain systems. The institution registration is handled by the smart contract in our system, and all the current institutions, they can vote on the new institution's participation. They will decide if they would like to bring a new institution into the consortium. And the institution can run multiple block operators. They will decide who are able to be the blocker operators inside their institution. and they will manage their own operator separately. So here, this screenshot shows we have the multiple institutions here. Each institution, they can manage multiple operators. In terms of the user management, it's conducted off-chain by each institution. We have these hierarchical structures. Each institution will manage their own users and corresponding permissions. And the user and the permission data are securely stored in an encrypted database. And we have administrator here, which will create users and specify their permissions, create an access policy list here. And users can also be organized with user group, and they can be managed by the user group. So the first time you log into this system, you will create an account like you usually do. Then you can add multiple users, as well as specify which group you want to put this user in. So within the group, you may have the regular user, and admin can add new users, add new groups, and put user into the different groups and assign the permissions. All the blockchain access is permission-based in the consortium setting. So a user and service will be issued an auth token after they log in. So this auth token is basically a JWT. This token contains the permission data. Currently, we are supporting read-write permission on all the chain APIs. So the token can be configured to expire. And each time you query an API, you need to attach your auth token together in order to request the chain node. So the auth token will be validated on the node gateway as we show in our architecture. We also can handle the layer 2 scalability in Pantheon. So the idea is your layer 2 service, if you have the high load of requests, you can batch them together, use a Merkle tree, and we only commit the Merkle root to the first layer of the chain. So in this way, we can improve the overall throughput. Last, I would like to encourage you to try Pantheon yourself. Basically, just a few simple steps. You can install Docker first and clone our repository. Make sure the following port are available in your system. Then you just run a very simple script. They will pull all the Docker image from Docker Hub and bring up the service. Later on, you open up the browser and visit this localhost as this port, like I did here. Here has different options you can choose. You can have the playground to send a query to the API gateway. It's a GraphQL query. Then you can return all the different results. From the dashboard, you can see all the blocks. If you click certain address, you can see all the hash and who is the sender and other information as well. We also provide a Grafana-based monitor tools to facilitate you to monitor your consortium blockchain systems, like the block height. If something happens, you can go here to try to figure out what's wrong with your system. And that's all for my presentation. It's a brief introduction for this solution. If you have any questions, welcome to contact us. Thank you.
So I've got one, Xinxin. So you were talking about smart contracts in your solution here, and typically, where do the smart contract, that code, where does it typically reside? On chain, off chain, in a block? Where is that smart contract?
Smart contract is deployed on chain. Yeah.
On chain.
Yeah, you just interact to call that contract address to trigger the execution of that contract by the entire network. Yeah.
Okay, so that code is sitting in a block along the chain, and you just need to know where to find that.
Yes, that has address for that contract. You can.
Yeah.
It's more like you send a transaction. You just call that contract at that particular address. Yeah.
Yeah. Okay. Great.
This is Anoop here. I got a quick question. So on one of your slides, you mentioned that the nodes or the members have the ability to kind of vote on admission. So kind of node or membership lifecycle management. Is that done through a kind of a group threshold signature?
Yeah. So yeah, it's a good question. So we try to support the more flexible policy here. It's up to you to say you can use a majority vote, or even you can run a type of consensus or use a threshold signature. I think it's just different options. We try to use a configure file to decide which policy you want to deploy. Yeah, in your particular setting. Yeah.
Got it. Got it. And so would that also extend to smart contract lifecycle management as well?
Yeah, smart contract lifecycle. Yeah, it's more related to the governance of your system, right? Yeah, we need to decide what's the government's rule to manage that the lifecycle there. Yeah.
Got it. Okay. Thanks.
Thank you.